So here is a common scenario when you have different data frames and you want to merge these data frames together. What do I mean by that? Say you have a data frame like this. This is data frame 1, data frame 1, and it has two columns. Say column A or column 1 and column 2. And then we have another data frame df2. This has column 1 and column 2. We want to create a new data frame 3, by combining rows from data frame 1 and rows from data frame 2. So we want all of these rows into this data frame. Row number 1, 2, 3, and then 4 from this data frame, 5 and 6. This is one way of merging two data frames. And we are going to explore all the different ways of merging data frames. Well, let's just create some data for ourselves so that we can start exploring all these scenarios. So here is our first scenario, the one that we have just discussed. We have two data frames of equal columns. We just want to merge them into a new data frame. So iris is the data set that we're going to use for this exercise. And what we are going to do is create a couple of data sets and then try and combine them. Basically, we're going to split iris into different data sets and try and combine. The way we are going to do that is something like this. So iris data frame has 5 columns, right? So there are 5 different columns, and the species column contains 3 different species: Setosa, and so many Setosas, and then Virginica, so many of them, 50 of them to be precise, 50, and then versicolor, just different names. So we have 50 each of these data rows. And then what I want to do is split this data frame into 3 different sets of data, or 3 different smaller data frames. So data frame 1, we're going to call it Setosa. Data frame 2 is going to be Virginica. Data frame 3 is going to be versicolor. This is only going to contain this 50 rows that are Setosa, and this is going to contain only those 50 rows that are Virginica and versicolor. So all we are trying to do is create ourselves some toy data frames, 3 of them, so that we can combine them together. So we are still in the process of creating the data for this whole exercise of merging. Okay, head of iris. So we know that it contains 5 columns. Now we're going to say Setosa equals iris of iris $species equals Setosa, and then all the columns. Let's see what it contains. Head Setosa. It just contains the Setosa species columns only, and since we are just seeing the head, if you're confused about it, you can just say how many rows there are. N row, which counts the rows of a data frame, N row of Setosa. This is 50, right? The first 50 of the original iris data frame. So similarly, we're going to say Virginica equals all the rows in the iris data frame that have the species name as Virginica. Okay, and then versicolor. Okay, so we've got 3 different sets of data, 3 different data frames, each containing its own species. And now we want to merge all of them together again. Now, we could do that using a command called rbind, R for row bind. Okay, so we're going to say iris, oh by the way, n row of Virginica is 50, n row of versicolor is also 50. So these are 3 different data frames, each 50 rows of the separate species. Iris underscore new, this is the new data frame that we're creating, is going to be based off of these three different data frames, and we're going to merge them using the rbind command. R for row, bind. So bind these data frames by row, not by column, but by row. And then you're going to say Setosa, Virginica, versicolor, right? Enter. And end row iris underscore new is 150, right? So these three different data frames, data frame 1, 2, and 3, each of them had 50 rows to start with. That's how we created these data frames. Then using rbind, we have combined all of them into one new data frame, and that has 50 plus 50 plus 50, that is 150 rows. In case you're still skeptical about it, you can just say edit iris underscore new. Then you see that these are all Setosa, right? So the first 50 rows would be Setosa, right? And then after that we have Virginica, because that's how we have binded them. I'm just scrolling through real quick. And then after 100, so and then at 101, we're going to start versicolor, right? So this way of binding data frames, one below the other, is done using a command called rbind or row binding. So this is probably the simplest way of binding data frames together. This is scenario 1, just the basic scenario. Now the second scenario is where some of the variables are missing, meaning in data frame 1, let's say, we have all these 5 columns, but in data frame 2, we don't have all of these data columns. Let's take this example. So here is our data frame 1. It has 5 columns, and then we have data frame 2. It has 3 columns. So the column definitions and data in 1, 2, and 3 match with this data frame, let's say. Meaning, let's say this is sepal length, sepal width, and petal length, right? And then this is going to be petal width, and this is species. And in the data frame 2, let's say we only have the sepal length, sepal width, and we don't have the petal data, but we have the species. This is species. This is again pretty common in scenarios where you tend to acquire data from multiple sources. Say you're trying to compare census data, meaning population and other statistics about population from different countries. So country 1, country 2, country 3, so on and so forth. And then you're trying to compile a common database, in this case a data frame, of let's say so many different attributes. Name, age, sex, occupation, so on and so forth. Now, some countries, like the United States, might have a whole wealth of data, but some countries in Africa, let's say, might not have all the data computed because it depends on the local government and what kind of statistics they do. So one data frame belonging to the US, let's say, has all the columns, and another data frame belonging to another country which does not have that particular statistic, maybe because they are not computing it, or maybe because that statistic is not relevant for that country. In which case you end up with data frames like this, where some of the columns are missing in one data frame, and another data frame might have all the columns. So in situations like that, when you try to merge data frame 1 and data frame 2, what happens? Well, let's see. Well, here we have these two different data frames. One is Setosa and another is versicolor. They have all the columns. Now what we are going to do is, let's say we're going to knock off these two columns and create a new versicolor data frame with just the sepal length, sepal width, and species. And we're going to try and combine or merge this data frame with the Setosa data frame. How are we going to do that? So we are going to create our test data set here by saying versicolor underscores or dot sepal, meaning this data frame is only going to contain the sepal data of the versicolor species, equals versicolor of, what do we need? We need all the rows, but we just need 3 columns, right? So we're going to need all the rows, and that's why we're not going to put anything on the left side of the comma. But on the right side, we're going to say we need sepal length, sepal width, species. So we only need these 3 columns. Okay. Now let's do a head of versicolor again. So instead of versicolor, we're going to say versicolor dot sepal, which is our new data frame. Right. So we only have 3 columns, and we're trying to combine that with the setosa column. So this with this. What happens? Okay, let's try that. R bind setosa with versicolor dot sepal. Oops, doesn't work. It says there is a mismatch, right? What do you do in cases like that? Well, there's not much we can do, because when we are trying to combine 2 data frames together, essentially what the system is expecting, at least using our bind function, is that the structure is exactly the same. Meaning data frame 1 should exactly be similar in structure to data frame 2. Now, in this case, it is not, right? So what do? You create these new columns, even though you don't have the data. That's the only way to combine these 2 data frames. And when you don't have the data, what do you populate it with? NAs, right? So what we're going to do is, because we don't have the petal data for versicolor, we're going to say versicolor.sepal. We're going to include the petal also this time. Dollar petal length equals NA. So it's going to fill all the columns of petal length with NA. Now that column does not even exist, right? That column does not even exist. So it's going to create a new column. And then similarly, we're going to say petal.width equals NA. Now, this data frame is going to be transformed into this data frame, right? You see, the petal length, petal width are all filled up with NA. Now we are ready to do that R bind. Let's try that again. R bind of setosa and this new data frame with a whole bunch of NAs. Now this time it would work. It would work. Let me just scroll up. It would work, but as you can see, all the versicolor rows have NA for petal length and petal width, but the sepal data, the first 2 columns, are okay. So, well, this is how you merge data frames that might not have the same structure because some of the data is missing. The example that we have taken is the countries data. When you try to collaborate and concatenate data from multiple countries into one huge giant data set, not all countries might have all the variables that you need. For example, social security number is a parameter. Well, you're not going to compute that because it's a sensitive variable, but let's say that's an example that we all know very well. That's available in the US, but not all countries have that kind of a number, right? In Europe, they might call it something else. In India, they might call it something else. In some countries, there might not even be a concept of a social security number. In which case, if there is a column against a country that says, does this country have some kind of a social security number? In US, there's an yes, and in some countries, there is a no. and in some countries there might be an NA because it might not be relevant for that country. So when you don't have data in certain columns of the data frame and you want to use rbind to merge them with another data frame, you use NAs and then try and merge. That way structurally you can do a merge basically. That data might not be all that useful because in this case half of these rows all have NA for sepal length, and half of these rows starting with 50 and 100 and ending in 100 don't have any data for petal length and petal width. So it might not be all that useful, but you might want to fill it up at a later point, right? Or you might do other kind of algorithms like averaging, or so there are so many different methods that you can use to fill this data. So if you want to temporarily just bind this data and do some analysis, yeah, this is the way to go. Another way to do is to drop these petal columns, the columns that are not available in the second data frame, drop those columns in the first data frame so that both these data frames are similar in structure. Then you can do the merge. So you can do it either way. It's up to you.